Okay, happy Easter, everybody. Welcome to the third lesson of Unit 10, where we're going to begin graphing equations in yet another form, the final form that we'll study in Algebra 1, which is vertex form. Okay, so in vertex form, we're going to analyze how the vertex affects the graph. So before we've done standard form and factored form, and now we're doing vertex form. So to kind of give you an idea of how vertex forms works, we're going to look at the things we've already discussed in regards to transformations of a parabola. We already kind of know what the a value does on a parabola. The a value tells me where it opens up or down, so which way it opens. It also tells me how wide or how narrow it is. Those are the two things that the a value says. And we kind of know now that if it's positive, it opens up, and if it's negative, it opens down. And if a is far from 0, it's going to be narrow, and if it's close to 0, it's going to be wide. So here's an example. If a is 1, well, that's the normal condition. If a is 1, it looks like this, where I'd go over 1, up 1, over 2, up 4, and vice versa around the axis of symmetry. So I'd go left 2, up 4, left 1, up 1, 0, 0. And this is the table method we've been using before, right? If I had x, then x squared, so I'd have negative 2, negative 1, 0, 1, and 2. I'd square it 4, 1, 0, 1, and 4. And then I'd multiply by the a value. And so for the first one, it's just a is 1, so it would be 4, 1, 0, 1, 4, and that's the graph I had. Now let's change the y value, or a value. Let's do a is 0.5, and we know that since that's closer to 0, my parabola should be wider. So now if I multiply my y values by 0.5, I get 2, 0.5, 0, 0.5, and 2. And so I'll graph that. I'll go 2 to the left, up 2, 1 to the left, up 1/2, 0, 0, over 1, up 1/2, and then up 2. You see now I have this wider parabola, like this, in blue. But if a is bigger than 1, we know that it's going to be narrower. So if I make the a value into 2, then I multiply all these by 2. And we've done this before, so I'm kind of going a little bit faster than I normally would. But you get the idea here. Instead of going up 4, I'd go up 8. And instead of going up 1, I'm going to go up 2. And so now here's my narrowest parabola. So you can see that how the a value affects the parabola. And so if it's negative, it's going to open down. So we know that. It's going to be the same as the blue one, except it's going to open downwards, like this. So that's when a is negative 1/2. Then if a is negative 2, it becomes very narrow. So I go 2 over 8 down, 1 over 2 down, 0, 0, like that. Okay, so I'm not doing much talking, but I hope that you understand what I'm doing here is I'm just basically using different values of a to show you how it affects the parabola. It tells me which way it opens and whether it's wide or whether it's narrow. Now this is one we have not done. We haven't tried to graph something where I had x minus a number squared. So y equals x minus a number squared. So we're going to start with 0 as h. So if h is 0, then the graph is y equals x minus 0 squared. And of course, x minus 0 is just x squared. So of course, if h is 0, I get the standard parabola that I know and love, like this. But what happens when I put in a different h value? What happens if I use h as negative 2? Okay, so now in this example, y equals h minus a negative 2. Remember, my original function was x minus h, and h is negative 2. So then I get x plus 2 squared. Now we're going to just take a look at what that does to my parabola. Well, if I put numbers in for x, I'm going to use the old method of graphing. I'm just going to plug numbers in for x and see what I get out for y. So I'm not using the parent function where I go negative 2, negative 1, 0, 1, and 2. I'm just going to plug in different values of x. So let's see what happens when I plug in 0 for x. If I plug in 0 for x, then I'm going to put 0 in here. 0 plus 2 squared. Well, that's just 2 squared, or 4. So for my purple graph, 0, 4 would be on the graph. What if I put in something like 1? Well, then I'd have 1 plus 2 squared. That's 3 squared. That's 9. So at 1, I have 9, and I'm quickly running out of room, so I'm not going to go more to the right. Let's use one that's farther to the left. Let's do -2. If I put -2 in there, -2 plus 2, that's 0 squared. 0. So -2 is 0. What about -1? -1 plus 2? Well, that's going to be 1 squared, or 1. So -1, 1. How about -3? -3 plus 2 squared. Pen is kind of being weird here. That's -1 squared. That's 1. So -3, 1. Do you see where my parabola is now? Let's do one more just to make sure. Let's do -4 plus 2 squared. That's -2 squared, and that's 4. So at -4, I have 4. And you see my parabola is now moved over a couple units. And you see that my parabola is the same shape. It's not wider or narrower. It's the same steepness, but it's been moved over. How many units? 1, 2. 2 to the left. So if I have x plus 2 inside the parentheses, do you see that? When h was negative, and that made a positive inside because I was subtracting it, x minus a -2, that made x plus 2, and I moved my parabola over 2 to the left. All right. Now, if I had x is positive 2, I know that we're kind of running out of space here, and I'm going to cheat because I can erase everything. So one moment, I'm just going to just erase all my writing here. What if h was positive 2? Y equals x minus a positive 2 squared. That's x minus 2 squared. Now you can see that my first parabola was right at the center. My second parabola, when h was -2, was moved 2 to the left. So I moved 1, 2 to the left, 1, 2 to the left, 1, 2 to the left. So what do you suppose is going to happen when h is positive 2? When h is -2, it moved to the left. When h is positive 2, it's going to move to the right. And I'm not going to spend the time this time to plug in the numbers. You can trust me that that's what's going to happen. So this h value, if I have something in parentheses before I square it, is going to move the parabola left or right. And so the h value, h is for horizontal. I'm going to move horizontally left or right. What about this k value? We already know from the last chapter what this k value is. It's the constant at the end. And what did that constant c do? Remember when we had y equals a times x squared plus bx plus c? What did that c value tell us? You should be screaming at your screen right now. It's the y-intercept. So if I have x squared plus 0, x squared plus 0, well, of course, that's going to be just the normal parabola with the y-intercept of 0. And I'm going fast here because I don't have a lot of time in the video, but you can kind of understand I would be graphing that using a table, -2, -1, 0, 1, and 2. Now if x squared minus 2, it's going to be the same parabola, but I'm going to move 2 down, right? Because that's the new y-intercept. So what do you think the k does then? If h is a horizontal shift, what's the k value? It's a vertical shift. K is a vertical shift. Right there. Okay? If k is positive 2, then you have x squared plus 2, and that's just going to move it up 2 units. Like this. And so now we've discovered independently what the parts of the form of a vertex equation is. So we've talked about the a value, how it makes it wide or narrow. We've talked about the h value that moves it left or right, and the k value that moves it up and down. And so let's complete this next page together. Now if a is bigger than 0, then it's going to open which way? So remember, a is bigger than 0. It opens up. If a is less than 0, if a is negative, it opens down. If the absolute value of a means the distance from 0 is bigger than 1, it's going to be narrow. If the distance from 0 is less than 1, it's going to be wide. All this means with these bars is absolute value, which means the distance away from 0. the vertex coordinate. This is what's really neat about this format. And this format here, up at the top of your screen, is called vertex form. This is probably the most important lesson part of today. So this is what vertex form is. Y equals A times the quantity x minus h squared plus k. And what's great about this is that vertex, the vertex of your equation, is going to be at the coordinates hk, which makes it super easy to find the vertex when it's in vertex form. This is not working out for me. There we go. H, and then the comma, and then the k value is the y coordinate of the vertex. And the axis of symmetry is x equals h. Whoops. Right? So let's give you an example. If y equals, let's do 2 times x, and let's do minus, and let's make h let's do -3. I'm going to square that. And the k value, let's make a -2. Well, if I simplify that expression, it's going to be 2 times x plus 3 squared minus 2. Well, h was -3, and k was -2. So where's the vertex of this? The vertex of this graph is going to be at -3, -2. So I'm just going to put that on my graph right now, -3, -2. That's the vertex. Which way does this graph open? Well, 2 is A. That's positive. It opens up. Is it narrow or wide? Well, 2 is bigger than 1 or farther away from 0 than 1, so it's going to be narrow. So to graph this, I'm going to use a table, just like we did before, with 3 columns. -2, -1, 0, 1, and 2, 4, 1, 0, 1, 4, multiplied by 2, 8, 2, 0, 2, 8. Remember, where do we graph these points? From the vertex. And guess what? The vertex is already given to us, 2 over 8 up. 2, 4, 6, 8. 1 over 2 up. 0, 0. 1 over 2 up. 2 over 8 up. And there you go. That's how we graph something in vertex form. And how nice is that they basically give you the vertex based on what the equation was. All right, let's look at another example. Now I have 2 times the quantity x minus 1 squared plus 3. Which way does it open? Up. Where is the vertex? Well, this is the tricky part, because look at what is inside the parentheses. You might think that h is -1, but remember, the vertex form is x minus h. So what would have to go in for h here? It's the opposite of what's inside. Opposite of what's inside the parentheses is the x coordinate of the vertex. So the opposite of -1, +1. And then k is going to be the same. So that's going to be the same as what it was. So same sign. So inside, it's the opposite sign. Inside the parentheses, you take the opposite sign. And for the k value, you take the same sign. So the vertex is at 1, 3. 1, 3. The axis of symmetry, x equals h. And that's the same value as the vertex, 1. That's my axis of symmetry. So you know it has to pass through the vertex. There's my axis of symmetry right there. We're going to use the table, and I'm going to go really quick here. -2, -1, 0, 1, 2, 4, 1, 0, 1, 4. My a value is 2, so multiply by 2, 8, 2, 0, 2, 8. Cross those out, and I'm going to graph that like you said, like you guessed it, probably just right from this vertex. So -2, up 8, 1, 2, 3, 4, 5, 6, 7, 8, to kind of guess a little bit. -1 up 2, 0, 0, 1, 2, 8, and there it is. There's my parabola. Vertex form is super easy to graph because they basically give you everything you need right away. They give you the vertex straight away. How about this one? Up or down? Y equals -x plus 5 squared plus 2. It opens down because of this negative sign. The vertex, opposite of the inside, so -5, same as the outside. 2, -5, 2. Axis of symmetry is x equals -5. So -5, +2, there's my vertex. It's going to open downward. Multiply by -1, so it's going to be -4, -1, 0, -1, -4. And there you have it, just like that. Very easy. Okay. And that's all we have time for in this video. The one thing I didn't get to talk about is when it's 1/2 and then everything goes straight as normal. I will see you soon. Have a good day.